Imagine a future where flying is no longer defined by long maintenance delays, expensive fares, and endless airport chaos. Think about how many times you've been stranded because a flight was canceled for maintenance, paid too much for a ticket while worrying about reliability, or had to drive hours just to reach a major airport because your local one didn't have service. That frustration is exactly what the 2026 Tesla super electric plane aims to eliminate. This new innovation is designed to change the way we travel by air. It shortens downtime in hangars, dramatically cuts the cost per flight hour, brings flight operations back to smaller local airports, making regional travel simpler, faster, and far more affordable. But what makes it truly shocking is how it might redefine reliability itself. Imagine a world where flights run on schedule by default, where affordable fares don't come at the cost of delays or cancellations, and where passengers can depart from smaller airports much closer to home instead of battling massive terminals. The Tesla Super
electric plane
promises less waiting, less spending, and a far more convenient travel experience. Before diving into the technology that makes this possible, Tesla's goal is clear: to make flight as reliable, cost-effective as electric cars have become on the ground. At the heart of this breakthrough lies modular electric propulsion. This means each power unit, or propulsion pod, combines everything it needs into one compact, easily replaceable system: electric motor, inverter, and propeller connected through standardized power, data, and cooling interfaces. When one of these pods shows a fault, technicians no longer need to spend days performing complex repairs. Instead, a 4-person maintenance team can simply remove the faulty pod and replace it with a fresh, pre-tested spare in just 4 to 8 hours. Once the swap is complete, a brief round of balancing and ground testing, taking only 30 to 60 minutes, gets the plane ready to fly again. Compare that to conventional turboprop engines, where even basic inspections can stretch out over a week. What once required 3 to 10 days now takes less than 1. That time difference alone reshapes reliability, keeping planes in the air instead of grounded in hangars. This modular approach doesn't just speed up maintenance, it completely redefines efficiency. Traditional turboprops demand 4 to 6 maintenance man-hours for every flight hour just to keep their power plants in shape. With Tesla's all-electric system, that figure drops to roughly 1 to 2 man-hours per flight hour. That's a 50 to 75% reduction in labor and cost, because these propulsion pods are standardized and pre-balanced. Airlines can maintain a stock of ready-to-go units. When an issue arises, you swap out a pod and send the faulty one to a central facility for repair and recertification, which usually takes only 2 to 3 days. This strategy cuts down on aircraft on-ground events known as AOG by as much as 30 to 50% and boosts on-time performance by 5 to 10 points. In real-world terms, that means on-time flights could rise from around 78% to between 86 and 88%. That difference translates to fewer missed connections, fewer overnight delays, and fewer headaches for both passengers and airlines. It also means the Tesla super electric plane can operate more easily from smaller airports, thanks to simpler maintenance requirements and lighter staffing needs. And the savings don't end there. Power plant maintenance makes up 20 to 30% of a regional aircraft's total operating cost. By cutting man-hours and downtime, a Tesla super electric plane can reduce cost per seat kilometer by 15 to 25%. For instance, on a 300-kilometer regional flight with 19 seats and an average seat cost of 20 cents per kilometer, the total trip would cost about $1,140. Tesla's efficiency improvements could save roughly $200 to $250 per leg, enough to meaningfully lower fares while still keeping operations profitable and reliable. Every swap and every maintenance action on the Tesla's super electric plane is tightly verified. For safety and consistency, after installing a new propulsion pod, the crew runs a series of standard checks: insulation resistance testing, pressure verification of the cooling loop, dynamic propeller balancing, and a multi-power level test lasting up to an hour. If needed, a short technical test flight is performed to confirm everything's perfect. Each step is digitally recorded, with the system automatically logging pod serial numbers, firmware versions, and diagnostic data to reduce recurring faults by up to 30%. This digital-first approach means maintenance is not just faster, it's smarter. One spare pod per 3 aircraft is usually enough to cover 95% of single-event faults in a day. In the past, that kind of uptime was impossible for smaller airlines. Now a week of hangar time turns into a one-day turnaround. Overall, this system cuts maintenance hours from 4 or 6 down to 1 or 2 per flight hour, reduces AOG events by half, boosts punctuality by up to 10%, and enables 1 or 2 additional short-haul flights per day, equating to a 10 to 20% increase in daily utilization. Which of these benefits would matter most to you as a traveler? Would you prefer shorter wait times from fast modular swaps? Cheaper fares thanks to fewer maintenance hours? Better on-time reliability? Or the ability to fly directly from your nearby airport? All of these are part of the same promise. Tesla is transforming the economics of regional aviation. One electric propulsion pod at a time, but modular design is just one part of the secret. The second lies in Tesla's fundamental engineering principles: simplicity through fewer moving parts. Electric propulsion eliminates many of the components that make traditional engines complex and failure-prone. A Tesla electric motor has only a rotor and a handful of bearings, no pistons, no valves, no camshaft, no turbocharger, and no gearbox. Traditional turboprops, with their intricate mechanical systems, require constant attention oil changes, fuel filter checks, turbine inspections, and leak tests. Each of these adds maintenance time and cost. Tesla's system removes all that clutter, with no combustion, no oil system, and no fuel lines under pressure. There's simply less that can go wrong in a typical turboprop fleet. Every flight hour demands 4 to 6 hours of engine-related maintenance. Tesla's design cuts that by up to 75%, meaning fewer delays caused by maintenance holds and fewer cancellations due to unforeseen issues. Since the Tesla Super electric plane lacks complex fuel and oil systems, the list of maintenance tasks shrinks dramatically. Gone are the days of fuel mixture tuning, hot turbine blade inspections, and soot removal. Instead, the focus shifts to quick electrical diagnostics and sensor verifications, routine A and B checks, which previously consumed significant maintenance schedules for regional operators, can be reduced by 30 to 40%. This further lowers downtime and costs while improving overall fleet availability. Another smart advantage of Tesla's electric design is regenerative braking. During landing and taxiing, the electric motors reverse function and act as generators, converting kinetic energy back into electricity to recharge the battery. This not only boosts efficiency, but also extends the lifespan of the wheel brakes and landing gear, which typically suffer heavy wear on short-haul aircraft. By taking on part of the braking workload, the electric motors reduce mechanical brake wear by up to 30%. On busy routes, this can extend service intervals for brakes and landing gear by 25 to 40%. In practical terms, a brake set that needs replacing after 802, 1,000 landings on a conventional plane might last 1,100 to 1,400 cycles on the Tesla Super electric plane. Each deferred replacement saves thousands of dollars in parts and eliminates hours of maintenance labor. These small improvements add up to huge financial and operational gains. When power plant and mechanical maintenance make up nearly 1/3 of an aircraft's total costs, every percentage saved matters. The combination of reduced man-hours, longer service intervals, and fewer scheduled checks translates into a tangible 15 to 25% cut in cost per seat kilometer. To put that into perspective, if a standard short route costs $1,140 to operate, Tesla's innovations save roughly $200 to $250 per flight without compromising performance, safety, or passenger comfort. That saving allows for more accessible fares, opening the skies to more travelers than ever before. All these changes mean a dramatic shift in how airlines operate. The Tesla super electric plane isn't just quieter or cleaner, it's fundamentally smarter and more efficient. A week's worth of maintenance is now done in a single day. On-time flights rise from the mid-70s to nearly 90%. Passengers save time, airlines save money, and local airports become viable again. The result is a travel system that feels personal, modern, and convenience, a stark contrast to the frustration of today's air travel. Tesla doesn't stop at simplifying mechanics. The plane also introduces predictive maintenance powered by over-the-air data updates. Each propulsion pod is densely packed with sensors, measuring vibration, temperature, current, and voltage. This real-time monitoring allows Tesla's onboard systems to detect early signs of wear long before a fault occurs. Instead of reactive repairs, the system predicts and schedules maintenance precisely when it's needed, no earlier, no later. Combined with Tesla's secure OTA over-the-air connectivity, software improvements, diagnostic patches, and even firmware updates can be sent to the aircraft remotely, much like Tesla cars today. This ensures every plane remains up to